In this video, we are asked to solve the Laplace transformation. We should use Laplace transformation to find the solution to this initial value problem. Okay, so to solve this is very simple. You write solution. If you write solution, then we are given that y prime prime plus 25y is equal to 10 cos t. Okay, now to solve this using Laplace transformation, the first thing you have to do is to take the Laplace of both sides. So you take the Laplace of both sides by saying the Laplace of y prime prime plus 25. Bring out this constant 25. The Laplace transformation of y, okay, is equal to, bring out the constant here. So 10, the Laplace transformation of cos t. All right. Okay. Now you should note that the Laplace transformation of y prime prime is gotten in this format. Just since it is raised to power 2, you will start with s squared and then you put the Laplace transformation of y. Okay. Now it's only this one that has 2 that will come with the Laplace transformation. For example, if we're asked to find the Laplace transformation of y prime prime prime, then it's going to be s3, the Laplace transformation of y. That is how to start it. Okay. Then if you have written this one, then this s will keep reducing, while the y will keep increasing. And then y must start from y of 0. So since it is 2, the next thing we are going to have is s raised to power 1. You now have y of 0. Okay. Then plus, now the s will now vanish because the next one will now be s raised to power 0. So it will vanish. So since this one is just y, it will increase to y prime of 0. You understand the pattern? Let me still explain using this one so that you understand it better. Now, since you write this one first, so the next one is that this one will decrease. So I'm going to have s squared here. And then my y will start with y of 0. So the next one I'm going to have, it will reduce again to have s. So this one will increase. I will now have y prime of 0. So finally, it will now vanish. I will now have finally y prime prime of 0. So that is the pattern it takes whenever you are taking the Laplace of a derivative. Okay, so we are going to apply it here now. So this one alone means s squared, the Laplace transformation of y. Okay, then, okay, not plus, sorry. The mistake here is that it's not plus, it's minus. Sorry, this is minus, not plus, please. Take note, it's minus, not plus. Okay, so we are going to have minus. So the next thing now is the s will reduce. So I'm going to have sy of 0. Okay, minus s will now vanish to have y prime of 0. Okay, all these things I've written is just for the Laplace transformation of y prime prime. So we're going to put our plus 25, the Laplace transformation of y, okay, which is equal to, now the Laplace transformation of this is what? 10 first. The Laplace transformation of cos t, the Laplace transformation of cos t, and then the Laplace transformation of sin t. I will tell you how to remember it. If you pronounce the word cos, you saw how I say it, cos. So s should be there. So this one is going to be s, we start it all over s squared plus, okay, let's have 80 here. Okay, let's have 80. Let me see my question. I think I omitted something in that question. Okay, this is cos 5t, please. Cos 5t. Okay, so correct your own. So I'm going to have a squared as well. So, but if you hear sine, there is a in it. So instead of s, I'm going to have a here. So this is 80 sine 80. So I'm going to have a here all over s squared plus a squared. So that is how you remember it. So let us change this to 5t. 5t, and then this is 5t. Okay, but you can solve with just t. If you are solving with just t, then your a becomes 1. Okay, but the main question, it is 5. So let's just use exactly what we have in the main question. So this is, I'm bringing out 10. The Laplace transformation of this is cos. So there is s. So the Laplace transformation is what? S all over what? S squared plus 5 squared. So please write your 5 and your s very well so that they will not look alike. You will not make mistakes. So from here, I'm going to have that let us bring out all the people that has Laplace transformation. S squared has Laplace transformation, and then plus 25 has Laplace transformation. And the only thing they have in common is that Laplace transformation of y is what they have in common. Okay, then minus this one. Now they gave us that that y of 0 is 2. So I'm going to have s in bracket of 2 minus, then y prime of 0 is 0. So I'm going to have 0 here. Remember that this one, I have attached it with this one. So it's equal to, this time this gives us 10s all over s squared plus what? 5 squared. Okay. Now having this, what do we do? This one is gone. So I'm going to take this one to this side. So I'm going to have that s squared plus 25 all in bracket of the Laplace transformation of y, okay, is equal. This time this will give us 2s. Going to this side becomes plus. So I have 10s all over s squared plus 5 squared. Then plus, because it's already minus, going to this side become plus 2s. Okay. Now the next thing to do is to make Laplace transformation subject of the formula. So I'm going to have that the Laplace transformation of of y will now be equal to 10s over s squared plus 5 squared all squared. Because this one is going to come to the denominator of this one and equally come to the denominator of the other one. So that is why I have all squared here. So plus 2s, please know the difference between s and 5. 2s all over s squared plus 5 squared. That is 5 squared, that is 25. Let me put this one to be 5 squared. So I'm dividing both of them by, in fact, I'm dividing everything by s squared plus 5 squared. Okay, I'm dividing through by s squared plus 5 squared. So dividing will make this one to be squared outside, then we'll now have this one. So the last thing we are going to do is now to find the inverse Laplace transform of each of those functions. Then we are good to go. Okay, so let us find the inverse Laplace transform of the both of them. Permit me to go and get my cleaner to wipe the board. Okay. So you can try it. As you are trying it, so permit me to clean here. Okay. So since we've cleaned here, we'll now have that to find the y that we are looking for. We're going to get the inverse Laplace transform of the first one, which is 10s over s squared plus 5 squared all squared. Okay, then plus the inverse Laplace transform of 2s all over s squared plus 5 squared. Okay, so you will look at this and see that this one is obvious. The 2 can come to the back here. So if the 2 comes to the back, I'm having only the Laplace transformation of s over this, which is exactly the same way of sine. So this is going to be, okay, the same way of cos, because in cos, s is going to be up. So these 2 coming outside, I'm left with cos this, cos 5t, right? Cos 5t. Yeah. So that is that. Now, but for this particular one, there is something I need you to know for us to be able to find the inverse Laplace of that particular one. Now, you should take note that the Laplace transformation of t cos at, okay, and the Laplace transformation of t sine at, okay, we are going to do the proof in our next video. In our next video, I'm going to prove this thing I'm about to write now. So that the Laplace transformation of this is equal to, this particular one is equal to 2as all over s squared plus a squared all squared. Why this one is given by s squared minus a squared all over s squared plus a squared all squared. Okay. Now, if you look at this now, let's make this to look in the pattern of this. So for it to look in the pattern of this, so let me just have this. Let us make it to look in the pattern of this. So I'm having the Laplace transformation of, the inverse Laplace transformation of what? This is 5 here. So bringing 5 inside here, I'm going to have 2 times 5, then times the s, all over s squared plus 5 squared, all squared. Okay? Why this one? I told you that I'm bringing 2 outside to have the inverse Laplace transformation of just s over s squared plus 5 squared. Okay? So having this, we are going to see that we have arrived to the final answer. And the final answer here is that 2 times a times s. So 2 times our a times s. So we're going to have that this is going to be t sine a is what? Our 5t. Okay, then plus this one is 2 outside, and you know that cos is one that starts with s. Cos is starting with s, so this one is going to be cos 5t. So that is that for that, and that is the solution to this initial value problem. So thank you very much for watching. Please don't forget to like, share, and subscribe to our channel so that anytime we drop a beautiful video like this, you will be the first person to be notified. Thank you very much. Bye-bye.